I think the neural network is the base fundamental fundamental technique for the current, the very popular deep learning network, deep learning technique. So if you want to get some knowledge about deep learning method, I think you first need to get some master the base concept of neural network, the base feed-forward neural network. So today's contents mainly include the flow chart, the procedure of image classification using machine learning technique. Since the neural network have the same procedure, but the difference is the representation, the mathematic model in neural network with other machine learning method. So the global procedure is similar. So first, I will introduce the flow procedure of the generic machine learning method. So what's the neural network? Neural network is one representation of the machine learning method. So as we mentioned in the yesterday, machine learning mainly include three components. The first one is a representation. This means the mathematical model. The second one is the evaluation criteria. We need to construct the loss function to optimize the neural network. So the third one is the optimization, mathematical optimization procedure. So for the second and the third, the evaluation criteria and the optimization is similar with other machine learning methods, but the only difference is the representation is the mathematical models. So as we know, there are a lot of insight already clarified in the information processing mechanism of a human being. Neural network is simulate this information processing procedure using machine. So in order to make difference from biology and neuroscience, is usually called artificial neural network. So neural network is initially developed in a supervised learning. Of course, it also can be used in unsupervised learning because this time limitation are only introduced the supervised learning. This means we need to optimize the network, the model using the training data, training set with labels. There are many applications, as I said, like other machine learning methods, including pattern recognition and data mining. In one word, neural network is an extremely nonlinear logistic regression. Yesterday, I introduced the mathematical model about linear regression. So neural network is unlinear logistic regression models. So let's first look at the flow, the procedure of machine learning with a given task such as image classification, dog and cat image classification. The first thing we have to do is collect the training data set for conduct supervised learning. the training dataset including the input image and their labels, ground truth, such as dog and cat. In traditional machine learning method, after collecting the training data, the traditional machine learning need to extract effective and discriminating features from the raw data, from the raw images, and then construct what kind of mathematical operation in our representation, construct a model, then use this extracted feature and their labels such as dog and cat to training the model. After training the model, we can use this already trained model to predict the final answer of the test image or a image without label. So here is give an example, such as with the given task for classifying dog and cat image. We have the collect image X1. This is a dog image, so their label is the dog. The second image is a cat image. This is denoted as X2. So their label is cat. We use V2 to denote it. So the second training sample is also a cat image. Their label is cat. So in traditional machine learning method, because the image is have many number of pixels, if we will use all the values, pixel intensity of the raw image, there will be a high dimension data. So of course, in this high dimension data, there are a lot of unuseful information. So in traditional machine learning, the first thing is to extract effective features, effective and discriminating features to first transform the raw data into more compact representation. Then use classification model to do the recognition. So another thing, because the label such as dog and cat is the count, is the text. So in order to conduct mathematical operation, we can't use the text information to do this. We also need to transform the text label dog and cat into digital number. So for a binary classification problem, such as in the previous slide we mentioned, for recognize dog and cat, we can simply encode the dog and cat as -1 and 1, or -1 and 0 is okay. So for binary classification, encoding is very simple. But for multi-class recognition problem, for example, for 3-class recognition problem, we need to recognize dog, bird, and cat. If we simply encoding this text label into 3 digital numbers, such as 1, 2, 3. Let's look at the difference between this encoded digital number, value. So the difference of the encoded label between dog and cat is 2. While the difference between the encoded label between dog and bird is 2. doesn't mean the bird is more similar to dog than cat. So it's okay. I think this is a very important problem for conduct machine learning, for use machine learning for classification problem. First, you have to encoding the text label into digital number. Then how we can encoding this text label into more reasonable digital number. Usually, in most machine learning image classification system, usually the popular encoding method is encoding the text label into a dimension vector for N.class recognition problem. Such as for these 3 class recognition task, dog, bird, and cat recognition problem, we can encode dog labels into 3 dimension vectors like 1, 1, 0, 0. This is each element represent the probability to one class, such as the encoded label for a dog image 1, 0, 0. The first element represent the input, the probability the input image belong to dog is 1, while belong to the second class bird is 0. Belong to the third class cat is 0. So this is the encoder, is the final encoder. While for the image, bird image, we can encode the bird label into 0, 1, and 0, which means the image, the probability the image belong to bird is 1, while belong to other class is 0. So this is the encoding ground truth encoding problem. So this also, the final encoded vector is also called the probability vector or one-hot vector. In current classification problem, most method encode the label into this kind of probability vectors. So this is when we want to classify dog and cat class using image. According to our experience, according to humans' experience, the first thing we need to distinguish what's the difference between the dog and the cat. What's the properties, what's the unique properties in dog image and in cat image. Let's first observe the different, the dog image, the dog class image and the cat class image. We can see the main difference between dog and the shape and the ear of dog, between dog and the cat is different. Also the eyes and our nose is also different. However, the number of legs is the same. Dog have 4 legs and cat also have cats also have 4 legs. And the color, the appearance color is also not also not a distinguished properties, because dog have different colors, appearance colors. Also, cat also have different colors. So in traditional machine learning technique, we first, according our experience, extract some very unique features, such as for dog and cat classification. We can extract the shape features of ear and the size of nose to distinguish the image is belong to dog and cat. So here is just a very simple example. If we have this, for example, we assume we already extract the ear shape and nose size as the feature for representing the dog and the cat image. We only use this two-dimension feature to distinguish or recognize the dog and the cat. So as we already said, we have to first construct the mathematical model, mathematical operation, define the mathematical operation in the machine learning, for construct a machine learning model. For example, we just simply construct a linear transformation model, such as we use, because the input is only two features. The input is only two features, the ear shape and nose size. This is a two-dimension space. We want to find this distinguished line in this two space. So this line can be represented in a linear form like this one. So X ear, this is the ear shape, can be represented by X nose by a linear transformation of the nose size. So what's the unknown thing? The one unknown thing is the W1 and the W0. W1 and W0. So the W1 and the W0 is the unknown thing. We want to optimize optimization in our training phase. As I already said, we already have collected the training samples, the images, cat images and dog images with their corresponding labels. So use this training sample, we want to find one optimal unknown parameter set, W1 and W0. Then use this W1 and W0, we can very well approximate the linear transformation equation, linear model. So this figure shows according. In this figure, we only show the raw image. For each raw image, they have the ear shape and nose size features. So from this figure, we want to find a best line which can will distinguish best distinguish the cat image and the dog image. From this figure, we can see this line. This line is a good choice, is a better choice. This line can classify, can perfectly classify all training cat image and dog image. So in order to get the unknown parameter W1 and W0, we use mathematical optimization method. So I think this is a mathematical optimization is a very difficult, is a very challenge task, but you already developed a lot of optimization procedure in the machine learning field. So maybe if you want to use it, you can use some toolbox to implement this function. So after we get this discriminated line, this line can best classify the training dog image and cat image. For an input test image with unknown labels, we can use this line. Look at this, observe the test image. What position of the test image what position of the test image in this 2D space? If the test image into the follow part, the bottom part of the blue line, this means the input image belong to dog class. If the input image in the upper part of the red blue line, the input image belong to cat class. Of course, if the training sample, we don't have a lot of training sample, maybe we can't get a very good models. The lines distinguish lines. So in order to get a better distinguished line, first thing we need to increase in training sample. We need to explore other features such as eye colors of cat and dog images. So what's the difference between the conventional, between the traditional machine learning neural network, between neural network and other machine learning method? As we said, in the linear transformation, we usually use very simple mathematical operations, such as we only use some linear algebra, such as with x input x, we use w is the unknown parameter, to multiply the x input and apply plus some bias, and then get the output. This is a linear model. In the training phase, the unknown parameter is w and b. In training phase, we want to search, optimize the w and b. Let the estimation by the linear model with the ground truth, the difference between the ground truth and the estimation with the using the model is minimized. So in test, after minimize this loss function, we can get the optimal W and B. In test phase, we can only observe the input, and then we use the already learned W star and B star to predict the corresponding VT from the input X, from the input XT. So the final answer is like here in the input test phase. So what's the artificial neural network model? So in the artificial neural network, there are several combined composition functions, not only one linear transformation, In addition, the EA model also use nonlinear function to transform some variable into nonlinear values. So here I just give this expression on EA model. Next, I will introduce the detailed operation in the EA model. So in this EA model, there are a lot of unknown parameters we need to optimize such as W1, W2 to Wn, and B1, B2 to Bn. So usually in neural network model, there are a lot of parameters because there are multiple layers in our neural network. So let's go to the artificial neural network. The content for the artificial neural network, we first introduce a feed-forward neural network. This is a hierarchical neural network. Then we introduce the activation function. This is a nonlinear function. So how do we optimize the neural network model? Is use error back propagation, and what's the evaluation criteria? There are some problem in neural network training, how we can solve these issues, such as we can use regularization of the neural network. Finally, is a summary. Neural network is a system composed of many simple processing elements that operate in parallel to acquire, store, and utilize experiential knowledge. Each element in the neural network is a node called a unit, also called a neuron. Units are connected by a link. Each link numeric weight, a digital weight. So this is the figure of the feed-forward neural network. So in this feed-forward neural network, there are only fully connected layers. So this is different from convolution neural network. So it's called, so in this connection is called full connected layer. This means in each layer, the output layer is fully connected all the unit, all the neuron in the previous layer. This is called a full connected layer. Here is an example, such as the first layer is called the input layer, second layer called the hidden layer, and the final layer called the output. Here is the three-layer neural network architecture. So input layer, we have D-dimension input. So the hidden layer, how many neurons, how many units we need to is defined, is designed according our experience. The output is according our task. the output dimension is according to our task. So, so as the definition, as mentioned in the definition, so we have the input for each neuron. There are 1 values. So there is the new unit of the second layer, the hidden layer, such as for this unit is connected with all the input unit. So in each connection link, in each connection, there are a weight. So the mathematical calculation is used like here, is expressed in the right hand. So xi is the S unit input. And VGI is the link, the weight is the weight in a link. So the output is the hidden layers, the GIS units. The AG is the output, the GIS unit of the hidden layer. So W is called as weight parameter, and WG0 called base parameter. So after we get the weight summation of the hidden unit, we use a nonlinear activation function to transform the EG into another values. So the second layer is have a similar operation, but the input and output is different. The output is the value of the hidden unit. So the output is the final layers values. So finally, the network output using a suitable. It also can be nonlinear, also can be a linear. Use a suitable activation function to get the final result. This basic mathematical operation calculation is a neural network. So here is because this neural network is very complicated. We give for one layer, we only use 1 unit in the output. And let's look at the mathematical expression. So the input is x1, x2 to xm. So for simplification, we don't use base parameter. So for each input, we have a weight, the corresponding weight, and then the input value multiplies its corresponding weight, and all the value summation add together. Finally, we use a nonlinear function. Function gets the output of this output neuron. So this is if the output is has only 1 neuron, we can use this function. If we have many neurons, the similar we have similar computation expression. So if we added the base, is also similar. You just put the double zero here. So of course we can use, we can express this summation calculation as a matrix form, like the right hand, total right hand. So this can be expressed as a matrix form. So in most materials, they usually express as matrix form. So this is this is the overall calculation expression for a hidden neuron, for one hidden layer from input to output. So I think is just combine different mathematical operation together. So activation zero there we have the weighted summation. We also have the activation function. So we have a lot of activation functions such as step function, sign function, and sigmoidal function, and linear function, and IELU function. So I just here give some example. You can look at, observe, learn, study this yourself. So in the neural network, there's a neural network. When we want to use how the neural network learn a task, so we need to discuss some issues. First, we have to prepare the training sample, encode the example as an input, and initial neural network weight, and using a learning algorithm to optimize the parameter and convert, then test phase convert output into a meaningful result. The procedure for classification task, the first one is we first need to input sample, training sample to network. So with the initial defined weight, we can get the network output is an n-dimensional vector. So because for classification problem, the output should be a probability vector. So because the output in the real output in neural network maybe have different values, maybe have the values less than zero. So we need to normalize the value into some meaningful values, such as the probability vectors. Then we can calculate the evaluation error using the cross-entropy, and then using back propagation to do parameter updating. What's the cross-entropy? Cross-entropy, here I show this cross-entropy equation. So x is the estimated predicted probability vector from the network with the ground truth, like the 1, 0, 0 is a ground truth probability vector. So we use this function to evaluate if the network state is good or not. So here is, I'll give you some example for the cross-entropy. You can look at study yourself of how the cross-entropy, why the cross can work in this classification. Maybe I can simply introduce this, such as for classify three fruit types using image banana, apple, and orange classification. If an image belongs to banana class, its true probability vector is 1, 0, 0. When the predicted probability vector by the neural network is 0.8, 0.1, 0.1, so the cross-entropy loss after accounting equation, cross-entropy equation, we can get the loss, the final loss is 0.09. When the predicted probability vector by the neural network is 0.3, 0.4, 0.3, the cross-entropy loss is 0.52. So this means if the predicted probability vector can have similar probability distribution with the ground truth, the cross-entropy can be minimized. So this is a very reasonable loss function for the classification problem task. So in most existing deep learning network, the loss function is usually use the cross-entropy. This loss function also have good compatibility with the optimization method SGD. So for learning, to optimization for network, we need to learn the bit in the neural network. We need to modify the network bit so that output vector is as close as possible to the true output vector, ground truth output vector. So the main procedure in this training, this neural network training is we first need to initial wait and keep doing iteration for each training sample X. In the training set, we first do forward pass to compute the output of the neural network, and then using loss at each output unit. For update the parameter, we use backward pass to calculate the gradient to the weight of the loss function, and then to update all the weight until the training set error stop or reach the maximum iteration step. This is the global overall procedure of the network training. So maybe we don't have time for this. I will skip this detailed example for the back propagation. So in order to maybe if our training sample, we don't have a lot of training sample, maybe our network is all fitting to the training set, but cannot work for test set 0. A lot of hyperparameter need to adjust, such as the hidden unit number. So this also need to adjust. This is a hyperparameter is also need to adjust in accounting our experience or accounting experiment. So of course, we also can regularize the neural network using some technique, such as we not only use the loss function error as the loss function, we also give some constraint on the weight, such as we can add this regularization term for to the loss function to control the model complexity, and then get more robust model for do our task. Finally, I think already time. Finally, I will give the summary of this lecture. So neural network is an extreme nonlinear logistic regression. So in the mathematical model or operation in the neural network, we have input. We use weight summation of the input as the next layer's output, and use nonlinear transformation to get the activation values, and then get the output. The weight summation can be called a combination function, and the nonlinear transformation can be called the activation function. So the weight learning, weight update, we need to minimize the error cost function by back propagation. So there are a lot of activation function linear and nonlinear. If we only use linear as in our neural network, it can be considered as a combination of linear regression problem. So we can also regularize our neural network and get some hyperparameter according to our experience and the experiment result. So that's all. Thank you.
Okay, thank you for the fulfilling lecture on neural network, Ms. Han. So I believe that the materials coverage already, like diverse, yeah, from the understanding of neural network, and then the difference of biology and neuroscience in example of applications such as pattern recognition and also data mining. And then you also explain about the flow of machine learning, label encoding, examples of tasks using machine learning, differences between machine learning and other machine learning, and also the basic of neural network and its composition function of the overall neural network. I think now it is time for us for the question and answer sessions. So please raise hands if you want to ask questions. Ms. Han, could you please stop the screen sharing so that I can see? Yeah, I can see the people who raise hands.
Okay.
Yeah. Okay. So questions, please. So we have roughly around 10 minutes to do the questions. So go ahead, the lecturers and also the students, if you would like to ask questions, feel free to do so. Questions, please. You can also ask some general questions, yeah. Okay, Dani Almakia, raise hands. Go ahead, you can turn on your mic and also your camera.
Yes, thank you,
please.
moderator. I will ask to Mrs. Xian Huan. I want to ask if we are talking about the data that is really happening, such as a disaster like a tsunami, earthquake, and the other, and we will model it using neural network. What do you think about it? Maybe we must simulate the data or the other. Maybe this my question.
Okay, thank you, Bapak or Mas ini ya, Dani Almakia. Associate Professor Han, you may directly answer.
You mean so you about the data, training data?
If the data is quite, yeah, Dani, you can.
Yeah, small data. If
small data.
Small data.
So so in the current deep learning network, we usually need to a lot of training data set, training sample for training a good generalization models. But usually in real application, maybe the data set that we can only get a small scale data set. So in traditional machine learning method, maybe the data set we don't need to a lot of training sample, but in deep learning network, we need to allow very large training sample. But fortunately, there are a lot of released learned model in the deep learning. In the deep learning network, for the deep learning, deep convolution network, they already learned by some generic image classification data set. So we can use this knowledge already learned training model. Already learned model as the initial state for begin our training for another task. This is also called transfer learning. So this in deep learning network, this is usually a popular used procedure strategy for solve the small data problem. Another very simple strategy, we can augment our training sample, such as for example, for if we do image classification, our training sample is very small, not so many training sample. We can augment the training sample using some simple transformation, such as we can flip left and right flip the image, and top down flip the image. So, but even the image is transformed, but their label is same. So we can increase the training sample number for training our machine learning models. There are different strategy for solve this problem. Of course, also there are a lot of research for solve these issues in the computer vision research community. One-shot learning and few-shot learning. If you are interested, you can check. I just give the example. So there are a lot of strategy can solve this problem. Okay for my answer.
Yeah, Jenny, what about the answer? Does it satisfy your questions? Yeah, or do you want to ask further?
Maybe it's enough for me.
All right, so the question from Danny has been answered by Masan. So why don't we open the second question maker? So if you want to ask, just raise your hand and then go live with it. And I think the committee has something for you as well, like a token of appreciation for the question makers. Okay, I think one more question from the audience, please. Anybody? Yeah. Can you please raise hands? You can ask, something more general if you want to. Like, what is it like to be a student in Yamaguchi, for example? Okay. Any other questions? Or maybe from the head of mathematics department, would you like to say something to Ms. Han about today's lecture, or maybe about some, other aspects that you need to pay attention to?
Okay, thank you, moderators today. I think the feature extraction is important task in machine learning or neural networks. Yeah. How to decide the important features in machine learning method?
Ms. Han, do you get the question?
Yeah. So about feature selection. So
Can you
give me
repeat again, probably?
Yes. Is about feature selection.
Yes. How to decide the features in machine learning method?
There are a lot of feature selection methods. Usually, yeah, for some task, maybe we can according our experience select according the experience of the for the task for the task to select some feature. Of course, there are some mathematical methods for select features. Such as sparse cooling, we can use loss. Lasso. Lasso is a sparse. You can select from a high dimension features. We can select a part of feature for the part of discriminating feature for our task is called lasso. And so, of course, we can use very simple counting the correlation. Each feature with the according the correlation, each feature with the ground truth level, we can select more discriminating features. But I don't think there are a general good method for all tasks. This is accounting task by task. So maybe different methods have different effect on different tasks.
Okay, is that answering the questions?
Thank you. I got.
Okay, right. So now because time is already up, so it is already 9:45. Thank you so much for the inspiring speech and also lecture, Associate Professor Xian Hua Han. And we will see you again, everybody, tomorrow, at the same time, 8:30, with, of course, more interesting discussion about machine learning. So hopefully today's lecture will be an inspiration to study more about machine learning, and because machine learning is seen as a crucial subject to be learned in 21st century era. So dear participants, the committee already sent you the attendance link in the chat box. You can click it and then fill it up. And thank you for your coming today, for joining the session. And I will see you again tomorrow. Thank you so much for the attention and also the attendance. See you tomorrow at 8:30, everybody. Thank you and salam. Bye-bye. Okay, so everybody may leave the room after you finish your attendance. I'll see you tomorrow. Bye-bye.
Orang jadi kasih ngomong kan,